Everyone, welcome back to another video. Today we're going to be going over the geometry and trigonometry content area for the SAT and PSAT math exam. Again, this is a pretty important content area, so make sure that you're understanding the concepts that we're about to go over. So let's first start with area and volume. So for area and volume, you need to be able to know the area and volume of various shapes and be able to apply it to problems that the SAT gives you. So let's start with area. We're going to do area of a few shapes. For example, a square. We'll start with the square. The area of a square is just going to be its side squared. Because remember, in a square, all the sides are equal. So basically, it's like length times width, side squared. That would be your area for a square. For a rectangle, it's pretty much the same idea, right? Remember, rectangles, you just have non-equal length and widths. So your length, your width, so your area is going to be length times width. Okay? Then another one would be like a parallelogram. That's another shape you could see. So a parallelogram kind of looks like this, where you have this as your height and this as your base. So the area of a parallelogram would just be base times height. Then we have area of a triangle, which, let's say we have a triangle like this. We have a height that is from the straight line height from top to bottom, and then the base. So in this case, our area would actually be half base times height, because two triangles would make up a rectangle. So half BH plus half BH would give you the BH for a rectangle, so half BH would be the area for a triangle. And then the last major shape you need to know the area of is a trapezoid. So let's say we have one that looks like this, where we have one base here, and then the height, right? So our area for a trapezoid would actually be half base 1 plus base 2 times your height. So that would be the answer for the area of a trapezoid. All right? So those are the major areas that you need to know. What a question that the SAT math section will ask you is like, if you change the dimensions of a shape, how does that affect the area of it? So like, if we were to, sorry, draw a better rectangle than that. Let's say we have a rectangle that's like 10 times 4, right? Let's say we increase the dimensions by, both of them by 20%. How much does this change the area by? So currently our area is 40. But if we were to increase the dimensions by 20%, right? 10 times 1.2. This is just making sure that we're adding on the 20% because we're increasing by 20%. So it would be 10 times 0.2, which would be 2, plus 10, which would be 12. And then 4 times 1.2, 0.2, 20% of 4 is actually 0.8, so 4 plus 0.8 is 4.8. So now, if we were to multiply 12 times 4.8, and I'm going to use my calculator here for that, if we were to do that, we'd have 12 times 4.8, which is 57.6. So let's say we want to figure out the percentage in which the area changed for the rectangle now with these new dimensions. We would do percent change would be your new minus old over old. Really, it's old minus new, but it's in absolute value parentheses, so you could write it as new minus old. You want your old to be on the bottom, though. So 57.6 minus 40 over 40 times 100%. So when we do that, we would get 44%. So it'd be a 44% increase in the area if we change our length and our width by 20%. So that's the kind of questions you could see on the SAT math section or PSAT math section for area. Unless it's asking you to straight up just find the area of the figure that you're given. Now volume, we're going to go over some important shapes that you should know the volume for. One of which is a rectangular prism. So if we have this and then we have the connectors, where we have length, width, and height. our volume is going to be length times width times height, okay? If you have a cube, which is basically a rectangular prism, but you have squares for faces, remember, squares, they all have the same sides, so your volume is going to be side cubed. It's going to be your first side, second side, and then third side, you're going to multiply those together. So S cubed, that would be your volume for a cube. And then another shape that you could have is a cylinder. So a cylinder that kind of looks like this. What would be the area, I'm sorry, the volume of the cylinder? It would be V is pi r squared h. It's like you're finding the area of the circle at the bottom, and then you're multiplying it times the height. That's basically what volume is in essence. It's just area times height. We have a cone. A cone's area would just be 1/3 that of a cylinder, so 1/3 pi r squared h. And then finally, the last one is a sphere. If you were to imagine this is a sphere, our volume is going to be 4/3 pi r cubed, where r is the radius. So sometimes you'll get questions where you're going to have like a composite shape and you're going to have to find the volume. And sometimes you'll have that for area as well. It's all about breaking it down into individual shapes and finding the area or volume of those separately and then adding them together to get the full thing. Other times you could get, if you were to like change the radius, how does that affect the volume or something like that? I'm going to do one where it's a composite shape one, because like we already did changing the dimensions one for area. Also, another thing you might get is like if you keep the same volume, what combination of radius and height would give you the same volume for like a cylinder, for example, right? So that's just being able to plug into the formula and making sure that it's the same, making sure like it's the same volume. But let's do a composite shape one with volume. Let's say we have this cylinder, right? We have two, and then let's say we have a cone on top of the cylinder. And let's say we want to find what is the composite volume of this figure. And let's say we know that our radius is 5, our height is 10, and the height of the cone is 6. All right, so our volume is going to be the volume of the cylinder plus the volume of the cone. So we know that our radius is going to be 5 for the cylinder, your height is 10, your radius is actually going to be the same for the cone because it's the same, like right here, right? It's the same because it's basically on top of the cylinder, so it have like the same radius. So 1/3 pi, 5 squared, and then your height, which is going to be 6. Important thing to note, guys, make sure you're using this straight line distance here as your height, not this, because these are like slant heights. Those would not be comparable. They're not the same as the actual like straight line height. All right, and then we'll simplify it here. 5 squared is 25 times 10 is 250. So 250 pi plus 5 squared is 25. Oh my god. 5 squared is 25 times 6 is 150 divided by 3 is 50 pi. So our volume is going to be 300 pi. Obviously, you can just do 300 times 3.14 and you'd get a decimal answer, and you pick the answer choice that is closest to that. All right. So that's the major idea behind volume on the SAT and PSAT. Moving on to congruence, similarity, and angles. So congruence, similarity, and angles, basically for congruence, you have like two different shapes that have the same sides and same angles. They're equal, basically. So like if this was a equilateral triangle, and this triangle, like let's say this is triangle ABC versus DEF, right? Same angles, and you're going to have the exact same sides. These are all equal to each other, okay? Similarity is a little bit different, though. Instead of all the sides being equal, it's going to be in a ratio. So in other words, it's like this triangle would, like its sides would be twice as big. So if this was like 5, 5, and 5, a similar triangle would be like 10, 10, and 10, right? They're all the same in that particular triangle, but when you compare it to the other triangle, like they don't have the same side values. Like it's a proportion, like each side in triangle DEF is twice that of it in ABC. So that's the idea behind similarity. You would write congruence like this. You'd write similarity like this. So that's kind of the difference between them. The equal sign is congruent. This is your similarity sign. So that's the idea behind it. We can kind of talk about triangles really fast now that we're here. If all your sides are equal in a triangle and it's 60-degree angles, then it's an equilateral triangle. If just two of your sides are equal, it's called isosceles. And if none of the sides are equal, it's called scalene. Make sure when you're doing triangle problems, you follow the triangle inequality theorem. Basically, the sum of any two sides of the triangle has to be greater than the sum of the other side. Like, the sum of it should be greater than the other side. Sorry, that came out weird. So, if I have, like, a triangle where the sides are, like, 2 and 2, right? The third side has to be, like, less than the sum of these two sides, right? Otherwise, it won't work. So, that's the idea behind triangle inequality theorem. Okay, now let's go over angles. Specifically, angle rules to know. Typically, you'll see angles like this. You'll have like two parallel lines that look like this. And then you'd have like a transversal that cuts through them. That's what this line is basically supposed to represent. We imagine these are like two parallel lines. And then we have like a transversal cutting through. And what this does is it creates us 8 different angles. And it helps us really understand the concept behind angle rules. So there's important angle rules to know. I'm going to write them at the bottom here so I remember to cover them all. So adjacent, vertical, same side interior, and then it'd be like displacement. This is not an official name, but I'll tell you guys more about this when we get to it. And then that's mainly it. I think you could do like opposite angles as well. Opposite, which we'll get to in a second. Alright, so adjacent. Basically, these are angles that are like bordering each other, like 1 and 2 right over here, or like 2 and 4. And basically for adjacent angles, the sum of the angles are going to be 180. They're supplementary with each other. Which means that if you know one of the two angles, you can easily find the other because you're doing 180 minus that angle. So like, let's say angle 2 was 30 degrees, right? For example, I can write a better 30 than that. 30 degrees. That means that angle 4 is going to be 150 degrees and angle 1 is 150 because those are the two angles that angle 2 is bordering. And that actually helps us illustrate the next concept of vertical angles. So these are vertical angles, 1 and 4. Basically, they're across from each other, like vertically. Well, more so like diagonally, but they're across from each other, just like 2 and 3 are. And basically, vertical angles are the exact same. So both 1 and 4 is 150. Both 2 and 3 are going to be 30 because they are vertical from each other. So vertical angles, they're equal, adjacent, they're supplementary. Same side interior basically means like on the same side on the like inside of the parallel lines, like 3 and 5 and 4 and 6, right? Those are going to be same side interior. Those are also supplementary. So that means 5 is going to be 150 and 6 is going to be 30. So these two are supplementary with each other. They're both summing up to 180. And then we can talk about opposite angles here. Basically, like 3 to 6 and 4 to 5, that's what I meant by opposite on the interior. They are the same, okay? And then the displacement one, the name is kind of blanking me at a minute. It's not called displacement, but basically, you could almost like take these 4 angles and kind of like correspond. That's the word. Corresponding angles. Oh my god, I finally got it. Corresponding angles. So angle 1 corresponds with angle 5. Angle 2 corresponds with angle 6. Angle 3 corresponds with angle 7. Angle 4 corresponds with angle 8. I'm going to write it down. That's the official name, guys. Corresponding angles. Oh my god, I finally got it. Alright. Corresponding angles. So, corresponding. So basically, it's almost like you can take these 4 angles up at the top here, and you can almost like match it with the 4 that are down here, right? 1 would go with 5, 2 would go with 6, 3 would go with 7, and 4 would go with 8, if that makes any sense. You can kind of just match it up. And why is this important? Because if angle 1 has a degree, if its measure is 150, and we're matching it up with angle 5, that also means angle 5 is 150. If angle 2 is matched up with angle 6, then it's 30. If angle 3 is matched up with angle 7, it's 30. If angle 4 is matched up with angle 8, it's 150. This is probably your best rule to use, corresponding angles. It's going to help you a lot, because then you just have to match up the angles on the different, on the different lines, and you'll be able to get the angle measure a lot quicker than having to memorize, let's say, same side interior, for example. So that's important. That's a very important rule. I'm so glad I finally got the name of it. If you guys watched my ACT math video on geometry, I couldn't get the name of it, but this is the official name, corresponding angles, okay? So you can match up the angles here, and they would be equal to each other. So that's the idea behind angle rules. Please, 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 please make sure you memorize these names and what they are. Adjacent is supplementary, vertical is same side interior is supplementary, opposite is same, and corresponding is same. Alright? That's how you memorize them. So I'm just gonna big start. You guys should memorize these. Alright. We're gonna move on to the next topic though, since we got a lot of material to cover and I don't want this video to be insanely long. Right triangle trigonometry. So let's talk about trigonometry really fast. Trigonometry, if we're given a right triangle like this, right? The longest side of the triangle is called the hypotenuse, while the other sides of the triangle are called legs. So when we're looking at the concept of trigonometry, it's about angle measures and sides. How do we connect those together? So if we have an angle here, let's say this angle, right? And we want to do the trigonometric ratios. So we have sine, cosine, and tangent using the mnemonic SOHCAHTOA. So what does that mean? So sine theta represents opposite over hypotenuse. So basically, compared to this angle, right, our hypotenuse is obviously this longest side. That's not changing. But the opposite does, depending on what angle you're looking at. So in this case, our opposite leg is going to be this one, because it's opposite to that angle. So it'd be like this leg over this hypotenuse for this angle. That's sine. Opposite over hypotenuse. If you want to find the angle measure of it, you would just do sine inverse of opposite over hypotenuse. That's how you do like the inverse of the trigonometric function to get the angle by itself, if let's say you were trying to find it. And we'll also talk about the reciprocal, because it's like another trigonometric function. So the reciprocal of sine, or hypotenuse over opposite, would be cosecant theta. That would be the trigonometric ratio for hypotenuse over opposite. Alright, let's move on to cosine theta. Cosine theta, AH, adjacent over hypotenuse. So again, this is our hypotenuse. It's always staying the same, but our leg that is adjacent, that's the one that's bordering that angle. So in this case, it'd be this leg. So that would be cosine. It's adjacent over hypotenuse. And the inverse of cosine is secant theta. That would be hypotenuse over adjacent. As long as you know one of the ratios, you'll be easily able to find the opposite by just doing the reciprocal. And then finally, we have tangent. TOA, OA. Opposite over adjacent. So in this case, we have the opposite, which is going to be, like we said, the one opposite to that angle, and adjacent is the one that's bordering it. They're legs, so you should not be using the hypotenuse for a tangent. So in this case, it'd be opposite over adjacent, and the opposite of tangent is cotangent theta, which is going to be adjacent over opposite. So that's the basic idea behind trig. There's a few identities that you guys should know. Specifically, I'm just going to list them here. You don't really need to know how to derive these identities. These are just if you need to use them. So tangent theta is sine theta over cosine theta. sine squared theta plus cosine squared theta gives you 1. And then the other two are a little bit tricky. I want to make sure I get them correctly. 1 plus tangent squared theta equals secant squared theta. And then 1 plus cotangent squared theta is cosecant squared theta. All right? So these are big. You guys should know these. I can't even draw a star. You guys should know these because you might need to use them in a trig problem. So again, you don't need to know how to derive them, just memorize them. All right? And then the last thing I want to talk about before we move on from right triangles is Pythagorean theorem and special right triangles. So back to our right triangle. Pythagorean theorem, basically, if we have a leg A, leg B, and hypotenuse C, if we know two of the sides of a right triangle, we can figure out the third by using the equation a squared plus b squared equals c squared. This only works for right triangles. So for example, if we have a leg of 3 and a leg of 4, right? We'd have 3 squared plus 4 squared gives us c squared. 9 plus 16 is c squared. So 25 is c squared, or c is 5, right? So this is like a 3, 4, 5 Pythagorean triple, for example, okay? Pythagorean triples are usually the major ones that you guys should know are 3, 4, 5, 5, 12, 13, and 7, 24, 25. Sometimes you'll deal with Pythagorean triples that are higher than that, but usually they're multiples of any one of these three. So you'll be able to, if you were to like reduce each of the sides of the triangle, you'd get down to one of these Pythagorean triples, okay? So that's the idea behind Pythagorean theorem. If you know two sides of the triangle, you can figure out the third. Only works for right triangles. Let's really fast go over special right triangles. So for special right triangles, there are two major types of special right triangles you should know. The 30, 60, 90 and the 45, 45, 90. So I'm going to call this one my 30, 60, 90. And I'm going to call this one my 45, 45, 90. So we'll do 45, 45, 90 first since it's a little easier to understand, right? Since your angles are equal to each other, both your legs are going to be x because the angles, it's like dictating the side that's opposite from it. So you have both x, and your hypotenuse would be x root 2. If you were to do Pythagorean theorem, it'd basically be x squared plus x squared equals c squared, where c squared would be 2x squared. You take the square root, you get x root 2. That's why that works. Your 30, 60, 90 is a little bit more complicated, but your 30 side, the side that is opposite of the 30-degree angle, like this one, would be x, that's your smallest side. The one that's opposite the 60 is going to be x root 3, and your hypotenuse is going to be 2x. Even if you just remember x and 2x, like your smallest side is x and your hypotenuse is double that, again, you can use Pythagorean theorem. 4x squared minus x squared equals 3x squared. Take the square root, you'll get x root 3. So also very important for you guys to memorize. All right, moving on to the next section of circle theorems. So we're just going to talk a bit about circles. So for circles, the major things to know in a circle are this, right? Let's first go over terminology. So this straight line from end to end and that goes through the center of the circle, this is the center of the circle right here, but this straight line that goes from endpoint to endpoint, we call that our diameter, right? And half of that, just from the center to one of the endpoints on the diameter, we call this our radius, right? These are very important to know when you're doing like area and circumference, right? Circumference being equal to 2 pi r or pi d, because 2 times the radius is the diameter. And circumference is almost like the length around or the perimeter, basically. And your area is going to be pi r squared, the radius squared times pi. All right, make sure you memorize these formulas as well. You're going to need them on circle questions. Some other terms for circles. If you have a line that's connecting from endpoint to endpoint like this, but it's not going through the center, we call this just a chord. It's not the diameter, because the diameter is the actual like longest distance from endpoint to endpoint on the circle, and it needs to go through the center. And then finally, if you have a line that's like touching the circle at one point, like right here, this is called a tangent line. And This point where it intersects, the angle would be 90 degrees at that point where it intersects the circle. All right, so that's some terminology. We're going to go over a couple concepts, though, about circles that are a little bit more niche, specifically arc length and sector area. So arc length, right? Let's say we have the circle. I know it's a pretty badly drawn one, but let's say we have, like, it's almost like a wedge of the circle, right, that we're cutting out. And let's say we want to find the length of this arc right here. How do we do it? So we're following a formula. There's a formula for both arc length and sector area. For arc length, it'd be your angle in degrees over 360 degrees equals arc length over the circumference of the circle. Because remember, like I said, circumference is like the length around the circle, or like the perimeter. So if we had, let's say our angle was 30 and our radius was 5, and we wanted to find the arc length, right? How would we do it? Well, we do 30 degrees, right? We plug that in for the angle over 360 degrees. We're using 360 degrees because that's a full revolution around the circle. It's 360 degrees equals your arc length over circumference, which is 2 pi r. So 2 pi times 5 in this case. So I'd simplify this ratio first of 30 over 360. So when I divide by 360 divided by 30 would be 12, so 1 over 12, and then I would cross multiply. 12 times my arc length, I'm going to call it AL, equals 10 pi. So my arc length is going to be 10 pi over 12, or 5 pi over 6 if we divide by the greatest common factor of 2. Now similarly, let's say we want to do the sector area of this sector, right? We know our arc length is 5 pi over 6, but what is the sector area? So let's say we want to find this area, all this area in the inside here. How would we do it? So we change just this part of the proportion. So instead of arc length, it's now sector area. And instead of circumference, it's now just the area of the circle. And that makes sense because we're dealing with area over area. So again, it's 30 degrees over 360 degrees in the circle. Our sector area is what we're trying to find. I'm going to call it SA. And my area of the circle is pi r squared, so pi 5 squared. Again, I'm making this 1 over 12. I'm cross multiplying. I get 12 times the sector area is 25 pi. So my sector area is going to be 25 pi over 12. So that would be how you do the sector area for that. That's mainly the biggest things that you're going to be dealing with when it comes to circles. All right, moving on to unit circle trigonometry. So first, before we talk about the unit circle, let's talk about how to convert between radians and degrees. We've been talking about degrees mainly right now, but radians is important. It's going to help you a lot to memorize stuff on the unit circle. So how do we go from degrees to radians? Well, let's first go over some established facts. 360 degrees is the same thing as 2 pi radians. So 180 degrees is the same thing as pi radians, all right? These are just two facts in math that you need to memorize. And knowing this is going to help us convert between radians to degrees. Because if we want to go from degrees to radians, we do degrees times pi over 180 to get to radians. And the opposite if we want to go from radians to degrees. Radians times 180 over pi gives us degrees. So these are also important conversions that you should know for exam day. So now that we know how to convert between degrees and radians, we're going to talk about the unit circle specifically. So I'm going to go ahead and I'm going to draw the unit circle. So unit circle, not a great circle, but that's okay. So we have 0, 90, 180, and 270. Okay, I know this side is a little longer, that's okay. 0, 90, 180, and 270. If we were to convert these to radians, this is also 360 by the way. If we were to convert these to radians, right, this would be 2 pi. This would be pi, like we said. So for 90, 90 is half of 180. So pi over 2. And then you can imagine as if for like each section we're like counting up by pi over 2. So like pi over 2 for the top, pi for the left. At the bottom it's going to be 3 pi over 2. And then 2 pi, which is the same thing as 4 pi over 2. So there's specific angles in here that you need to memorize. So mainly 30, 45, and 60. So 30 in terms of radians, right? If we were to do 30 times pi over 180, we're going to get pi over 6. 45 is pi over 4. And 60 is pi over 3. So now it's important to memorize these trig values that I'm about to give you, all right? And we're only going to worry about the first quadrant because you can apply, these are like, we call these reference angles, the ones in the first quadrant. Because if you're asked to find a trigonometric value of an angle that's in like the second or the third or the fourth quadrant, it's the same values as what's in the first quadrant. The difference is the sign might change depending on what quadrant you're in. If you're in the second quadrant, cosine corresponds with x, sine corresponds with y. So if you're in the second quadrant, your x or your cosine is going to be negative while your sine is positive. In the third quadrant, your cosine and sine are both negative because x and y are both negative. And in the fourth quadrant, your cosine is positive and your sine is negative because your x is positive and your y is negative. So I'm going to create a table here. Cosine, sine, and tangent. All right, these are just values you have to memorize. So we're going to start with, for 0. Cosine of 0 is 1, sine of 0 is 0, and tangent, which is sine over cosine, that's going to be 0. Okay? For pi over 6, for pi over 6, pi over 4, pi over 3, pi over 2. Okay, we're going to do pi over 2 because that's also pretty simple. Your cosine here is 0, your sine is 1, and your tangent is actually undefined because you cannot divide by 0. That's not possible. All right, rewriting this 180 in here so I have space. So pi over 4 is pretty simple. Both cosine and sine are the same thing. They're both root 2 over 2. Your tangent's going to be 1 because you're dividing the same thing over the same thing. Now, pi over 6 and pi over 3 can be a little tricky, but the values are either going to be 1/2 or root 3 over 2. So as long as you memorize one of them, you'll be able to figure out the other by just flipping it. So for example, pi over 3, your cosine is 1/2, your sine is root 3 over 2. For cosine pi over 6, it's the opposite. Root 3 over 2 is your cosine, 1/2 is your sine. How do we figure out tangent? This is also pretty easy to remember. For tangent pi over 3, it's root 3, and for tangent pi over 6, it's root 3 over 3. You can imagine it's like root 3 for pi over 3 because like 3 and 3, those match up. And it's root 3 over 3 for pi over 6 because 3 plus 3 gives you 6, right? Those kind of match up like that. So that's how you would try and memorize these. So I'm going to pause here if you guys want to like take a note of this down. These are very important to memorize. And again, you just need to know, this is supposed to be a 3 by the way. You just need to know one quadrant and you'll be able to apply it to the other quadrants. And one quick thing, if you see a angle that is greater than 2 pi, like if you want to find, let's say the cosine of 30 pi over 4, right? That's greater than 2 pi. You basically want to take this angle and subtract by multiples of 2 pi until you get down to a unit circle angle. And then it's the same cosine that it's going to be. So if we were to do this, right, subtract 30 by 4, we would subtract 8 pi over 4, subtract 8 pi over 4, subtract 8 pi over 4. We'd get down to 6 pi over 4 or 3 pi over 2. What's cosine of 3 pi over 2? Our reference angle is pi over 2. It's going to be 0. Okay? So that is how you would work unit circle trig. Typically, if you're asked questions here, it's asking like cosine, sine, or tangent of a particular angle. Okay? So that is that. Last topic we're going to go over is, I believe it's circle equations, if I'm not mistaken. I'll quickly check. Yep, it's circle equations. So for here, it's all about what is the equation for a circle, how do we graph the circle, and how can we find the equation of a circle. So equation for the circle, this is your formula, right? X minus h squared plus y minus k squared equals r squared. Now, what does this mean? H comma k, these two values here, this represents the center of the circle that you're dealing with, while this r represents your radius. And it's r squared for the equation, so if you're finding the radius, you're taking the square root. So for example, if we have the equation x minus 2 squared plus y minus 4 squared equals 16. What is the center? What is the radius? And then we're going to graph it. So the center is going to be 2 comma 4. Remember, guys, the minus sign is already part of the equation, so it's positive for your center. If it was a +2, then it would be -2, but it's -2. So 2, 4 is your center, and then your radius here, 16, right? It's r squared, so our r is going to be the square root of that, which is 4. Remember, positive square root of it, so it'd be 4 for the radius. So if we were to graph this now, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I know this is not going to be the best graph because it's going to like extend outside, but just trust me here. So we're plotting the center first, which is 2, 4. So we plot this here. And then what we're going to do is we're going to basically like count out 4 in each direction to get the circle. So we're going to go to the right 4, which would be here. We're going to go to the left 4, which would be here. We'd go up 4, which would be here. And we would go down 4, which would be here. So this here is approximately our circle. And this would be our radius. See how it's 4 in every single direction, which makes sense. That's what a radius should be. So that would be your circle. If you're asked to write the equation of a circle from a graph, center is the first place you're looking, so you can get this part out of the way. And then count how many spaces in one direction from the center to one of the endpoints. That will give you your radius. And remember, you got to square it to get your radius squared for the equation. Last thing I want to cover with circle equations before we wrap up is completing the square. So like what happens if you're given an equation like x squared minus 10x plus y squared plus 6y equals 2. No. Equals 2. And actually, actually this works out perfectly. Okay, and what happens if we want to get this into a circle equation? We need to do something called complete the square. So completing the square, basically we're going to take the x terms by itself and the y terms by itself. And for completing the square, basically it's like you are going to be like making this into a perfect square trinomial. So that way we can get it into that x minus number squared form. So to do this, we're going to take this value here, this -10, we're going to divide it by 2. We're going to get -5, and then we're going to square it, and we're going to get 25. So that's how you would complete the square. Same thing for the y squared here. We're going to take half of the term attached to the y, or the b term in this, because remember this is like a, b, c for your trinomial. So half of 6 is 3, squared would be 9. So what we do to one side of the equation, we have to do to the other. So we add 25 and 9 to the right side of the equation as well. So when we do this, this becomes now x minus 5 squared, right? Because that's what we did. 10 divided by 2 is 5 to get that 5 squared. And then y plus, this would be 3 squared, because remember we did 6 divided by 2, 3 to get that 9, equals 36. So what's the center here? 5 comma -3, because it's a plus now. And your radius would be square root of 36, which would be 6. That's your radius, okay? Make sure you understand completing the square. You can get this question on the SAT or PSAT. Remember to complete the square, and whatever you do to one side of the equation, you have to do to the other, so that way the equation still holds true. All right, everyone. So again, I apologize for this being a long video, and really all the content area videos being a long video, but long videos, but there is a lot to cover, and again, I want to give you as much content and information as possible so that way it's fully comprehensive. So please make sure to like and subscribe. Please let me know if there's anything I can do to help. Thank you all so much for watching, and I will see you guys in the next